All right, let's see if we can develop a cool trick quickly. Okay, cool trick. If I want to find the area of some shape, right?
Yeah.
I would integrate over that shape, 1, the area, right? Okay, but now I have this Green's theorem business, right? Which means that I can convert this thing to an integral over a closed curve C. Right, I have a thing. Green's theorem converts area integrals into
Two curves, doesn't
into some kind of line integral, right?
it? Yeah.
You guys see that? That was astonishing before, right? And still should be, that somehow the area under a curve is related to the circulation around some line integral, right?
Yeah.
Okay, so let me think. If I'm going to apply Green's to this thing, right? I should have a P and a Q here, yeah? And the P and the Q there should be related to 1 over here. How?
Equals Q minus P. Get that stuff.
Oops. The
Then
partial of Q with respect to
X.
X minus the partial of P with respect to Y. So this is the kind of neat trick, is that you get to pick the X and the P and the Q for this. You guys see that? So can you guys come up with pairs of P's and Q's that work? So what's the easiest pair, P and Q, so that you get 1 out of this thing?
2 minus 1.
Okay.
Oh, sorry, P.
So
Backwards.
if I get 2 minus 1, right?
So
That means
2x
Q needs to be 2x, and Y needs to be,
Y.
or sorry, P needs to be Y. So that when I differentiate with respect to X and Y,
Yeah.
I get this kind of weirdness. Okay, although I believe that's the first one you saw, I don't think that's the easiest way to express 1 as a difference.
X, Y, and X, Y. Well, no, that would work. That'd be 0.
or X,
Yeah, good. Y and 0. So if I have 1 and 0, right? How do I get, what's the Q to get 1?
X.
X, and the P is
0.
0. And then another one, right? I could do 0 and -1, right? So what do I put in for Q?
0.
0 is probably easy. And for
Y.
P,
Negative Y.
-Y. Of course, there are lots more options, right? You could kind of keep making these things forever.
Yeah.
But one thing I should notice, right, is that I can do that double integral over a region D of 1, the area. One way I could do that is I could pick, like, maybe this one.
Yeah.
And I could write this as the integral over the curve that bounds this thing of what? X dy?
Yeah.
Yes. You want a nice, easy example for using this trick?
Yeah.
How about a piece of engineering? I'll tell you about a piece of engineering.
Okay.
Planimeter.
Planimeter. Planimeter.
I just can't remember how to spell this silly thing.
Planimeter.
So there's a little toy.
Planimeter.
It's not really a toy. It's actually a really cool piece of engineering called a planometer or a planimeter or something.
Planimeter is more likely to.
Where this is either an O or an I.
Okay.
Oh, we were doing this, right? Vowel 1, or vowel 1 is appropriate.
Planimeter.
Okay, pick an appropriate vowel. Go check these things out. They're super neat. It's just a little gizmo that you can trace around a curve, and it'll tell you how big the inside area is. It's actually a very cool gizmo.
So again, technology's rendered all of this useless. This is technology.
Yeah, so this thing is extremely cool in that as you draw, right, like it's kind of a double thing, right? So you draw around a curve like this, and it draws a
Perfect circle.
line on the other side. And the length of this line is the area of that thing. Yeah, I'll put a link in the YouTube video description to a picture of one of these.
It's an eye.
It's an eye.
It's the only thing.
Planimeter.
They're super cool. So what it does, right, is it adds up around the curve the x values times the change in y,
This
right?
one's digital.
Yeah, there's digital ones, there's radial ones. So there's ones that do this in polar coordinates and ones that do it in Cartesian. They're the same
I
idea.
like this one.
They're really pretty pieces of engineering from the kind of, yeah. You want me to hold that up at the camera?
Yeah, don't break my headphones.
Yeah.
Oh god, I touched it.
Make it go back.
This one. Try to make it
Sideways.
bigger.
Pull it sideways.
There you go.
That one.
Oh god.
Just
That's
about
involved.
Smash!
You're so upset.
Alright. I need to stop this video, it's getting really long.